Hello and welcome to SudoKanard. We're here to solve this 9-pin Sudoku, a practice puzzle by French author Sylvain Caudmont. This variant is quite unusual and it will be featured in the upcoming WPF Sudoku Grand Prix, and I haven't taken the time to have a look at this variant yet. I just explained. So in this variant, for each digit, you're supposed to enter them in the grid in a configuration like this, or perhaps I can use real digits, meaning that you have an alignment of 3 identical digits diagonally in diagonally adjacent cells. So for each of the digits, you must achieve this. So from what I have gathered, there are only so many places where you can do that. Well, this is such a place. And so by symmetry, you have those similar places. Another place is this, and you also have this, but you can see that only one of those 2 places can be used. And the same is happening in here, oops, and in here. So those green places don't interact with each other, but with the red places, only one of those 2 can be used because, well, there's this cell in common, and there are other places which are, let's use some gray, in here, oops, and then we can use 2 of them. We can use those opposite diagonals or those opposite diagonals. Perhaps I should use another color to say that I can use both blues or both grays, but I can't use this and that at once. I can't use a gray and a blue. So those are the only places where the identical digits can go. And the good news is that there are only 10 places. Well, there are more than 10 places here, but considering we can have at most 4 greens and at most 4 reds and 2 from those, that's a maximum of 10. So there's not that many degrees of freedom. And now let's try to do something. Well, the first thing I'm noticing is that by just the plain rules of Sudoku, I can place a 7 here, which is certainly good news. There has to be a 2 in one of 2 places here. And if 2 could be a repeated digit along this diagonal. And I'm thinking I should probably focus on digits that have a large number of appearances in the grid. I'm thinking of 9, because 9 here and here. Where could it be repeated 3 times? Well, definitely not on this green, not on this green, not on this green, but perhaps on this one. 9 in those 3 cells makes sense. What about red? It can't be on this one, it can't be on this one. Not this one, not this one, not this one. Not this one, but this one and this one are possible. Well, doesn't seem so easy. Definitely not. And could it be on this gray? No, it could not. On this blue, it couldn't. But On this gray it could. On this blue it could not. On this gray it could. So 9 will have to be repeated in this area, which then again makes sense because, well, there are restrictions on 9s. But here is an important point, I think. Yes, that seems to be very important. 9 will have to be here, just by Sudoku. And on whichever cell it goes, we can see that 9 won't be repeated on the corresponding line. And that's interesting, because we know that there are 10 places that can have a set of 3 identical digits. And those 10 digits counted the 4 greens, and we already know that one of those 2 greens can't have identical digits, because one of them will have this 9, and therefore won't have 3 repeated digits. So it means that our degree of freedom has just vanished. So that these 2 greens will have repeating digits, and all four red cells, all 4 red lines will have 1, and one of those 2, either the 2 blues or the 2 grays. But let's focus on this green line. So what is the repeated digit? It's not any of those digits. It's not a 7. So there are still, it's not a 4. So 1, 2, 4, 5. It has to be 3, 6, or 8. So that's not a 2. And the 2 is here. So now could it be a repeated digit? At this point, it could very well be a repeated digit. So, well, that's a start. Let's move on to this green set of repeating digits. So it won't be any of those 3 digits. It won't be the 5. It won't be... There are not that many restrictions on this set of repeating digits. That's unfortunate. Well, so where is another place to look? So this is from 1, 3, 7, 8, and 9. Well, this is really not that useful at this point. So 2 could be here. Where else could 2 be? 2. Well, we have 4 instances of digit 2 in the grid, so we looked at 9 earlier, but 2 seems to be very constrained for the repeating stuff. I'm thinking of something else. We know that... No, sorry, that was nonsense. There has to be a 2 somewhere here. So a 2 here would be good news for the repeating 2. 2 here would just not work, because I know that on this red line there has to be a set of 3 repeating digits. So either this one or this one, but with a 2 here it doesn't work, because 2 can't be here. Well, so 2 won't be repeated on here. And if I try the 2 here, I can't repeat the 2 on this part of the line. So that's not a 2, there's a 2 in one of those 2 places. And I'm just thinking, yes, the repeating digits are either the grays or the blues, but those digits will always be repeated, be it on the gray part or on the blue part. So that's very important. So those digits here will have to be repeated, and those are definitely constrained. Let's have a look at this one. Well, it's not that constrained actually, but let's write down the possibilities. So 1, 4, 5, 6, 8. This is 1, 2, 7, 8, 9. 1, 6, 8, 9. And here, this is from 1, 2, 7, 8, and 6. So now we must have identical digits here and there, or the other way around, here and there. So what could they be? 7 here doesn't work with either this or that. And the same is true here, so 7 is not an option. 5 here will never work. 4 will never work. That's interesting. 2 here will never be repeated in there. And this is very interesting, because now 2 is not here, it's here. And it looks like this could be the repeated 2. But let's wait before jumping to conclusions. So what is happening here? 8 could be repeated anywhere here. 1. Well, a lot can happen. 9 could be repeated on this, and there any digit here would be repeated. Or it could be the blue option with 1s here, or 8. Here it could be 1, 6, or 8. So there are lots of options. And I can't pencil mark those cells because I don't know whether the blue option or the gray option is the one that will appear in the final grid. But I'm feeling that something has been happening here. Well, what next? This 7 here is somewhere there. And an interesting point is that if 7 is here, knowing that 7 can't be here, then this is not the repeating set. And this will have to be, oh, I've been forgetting something. So I know that on each red line, either this or that is a set of repeating digits. So in every instance, those are repeating digits. That's interesting because 3 is never the repeating digit on a red line. And 3, no, sorry. Yes, that's correct. 3 is never the repeated digit on a red line. And we've already seen that 3 is not repeated on those lines, so 3 will be the repeated digit on some green line. And that is a breakthrough, I hope. 3 could be here, well, it could be on basically any red line. So, any green line, sorry. So that's another point of interest. So those digits are necessarily repeated on either side of the red line. But there are many candidates for those cells. Many candidates. Not that many, perhaps. So this is never 3, 4, 5. What else can it not be? This is not easy. Well, the puzzle in the actual round will be worth 80 something points, so it should be difficult. Ooh. That's a 9. And this is not a repeating set. So that's the gray line that's not repeated. So this, that's the green line, sorry, that's not repeated. So this green line is repeated and it can't have the 9, so the 9 is here. Now I must have a 9 somewhere in here. And now what? So this is a set of repeating digits. What choices do we have? This can't be any of those digits, and no other value is to be discarded. So 1, 2, 3, 5, 8. This is really not easy. So now one interesting point is that wherever I put the 9 here, it will be a repeated digit, I think. Because apart from the green lines, all the repeated lines go into the central box. So all the red cells here are repeated cells, and 2 on some diagonal here are repeated. So 9 here would put the 9s there, and this repeated digit here, but 9 here would be repeated on this side. 9 here would be repeated on this side. And then let's just consider that. If I repeat the 9 here, then this can't be a 9 anymore. And it won't work, because there's another way of seeing that. Because of this 9, 9 is somewhere in here. And actually 9 can't go there, because we know that the digits here are... Oh, actually it could be there. 9 could be repeated on this line. But what was I saying? Oh, I don't remember. I was saying if 9 is here, it must be repeating there. And then by Sudoku, the 9 goes here, and it will be repeated on this green line as well, and that doesn't work. So the 9 can't be here. Is something similar happening here? If 9 is here, it must be repeated, but not on this side because of that. Will it be here? If I'm doing this, then by Sudoku I get a 9 here, and it must be repeated, and that doesn't work. So that's not a 9, and this is a 9, and this could be repeated. I'm not sure I have proof for that at this point, but I suspect that I do have proof for that. First, I'm just wondering if there was a simpler way of eliminating this. So now, we know that 2 cells on this diagonal or this diagonal will not be repeating digits along those lines. So if the repeating digits are on the blue lines and not on the gray lines, then it will mean that those must be repeating on the green lines. But then this 9 can't be repeating on any green lines because, well, those have been excluded already. And this is not available because of this 9. So the only place where 9 can repeat is now this gray line. And we know that this is also a repeating set with either 1, 6, or 8. I think I'm getting somewhere now. And now 4 is much more restricted because 4 can't be repeated on any of the green lines, so it must be repeated on some red line. And it won't be any of those red lines, any of those. It won't be this one. So it could still be here. It won't be here. So the only line that can have 3 4s is this one. 4 is done. Now I must think of 5 and 7, I think. Two is really suspicious here, but I guess 2 could still go here. Then we could have a repeated digit in here. Perhaps I should do Sudoku first. The options here, this one goes there. Could one be repeated here? I guess it could. Those here are from 3, 6, and 8. What could this digit be? It couldn't be a 1 anymore, because if I put 2 1s here, I have no value for that. And actually, the digit that is repeated here must be there. That's really something. The digit that is repeated here must be there. And it can't be the 9, so it could be the 1 or this digit. But there's something to it. But first, so the digit that is repeated here must be in here. It can't be the 7, so it's the 2 or the 5. That is definitely interesting. The digit that is repeated here must appear in here and in here. Now, it can't be the 7, it can't be the 9, it can't be the 7 because there's a 7 in here, so that's not a 7. So this digit here is this one. We use some more coloring. This digit here also appears there. And we know that those are repeating digits, and it must also appear. No, that doesn't work. Oh, that's the 3. This digit is the 3 because, well, this digit is nowhere in here. It's nowhere in here. It's not the 4 because it's already been repeated. It's this. These are also digits that have already been repeated. So that this has to be the 3. So that can't be the 3 anymore. Now 3 goes there by Sudoku. Those are from 1, 6, and 8. And here I get a 1, 6, 8 triple, so this has to be 2 or 5. And now because there's a 2, 5 there, here, and a 2 there, this has to be a 2, and now 2 is repeated. I feel like I'm going somewhere, definitely. I still need to place 7. and 7 is not here. So the only place 7 can be repeated is here on this red line, and because of this 7, the repetition is in this orientation. So do we have all red lines? Almost. So we have placed 2, 4, 9, 3, 7. We are left with 1, 6, 2. Oh, we've placed the 2 here, so this is the 5 finally. And that's the 2. And because of that, there must be a 5 somewhere here, but 5 has already been repeated, so that's the 5. And this is also a digit repeated on some green line. So what can it be? No. It's not the 3, not the 5, not the 2. This is from 168. Oh, it's this one, sorry. So this digit is the same as this one, so it's not a 1, it's a 6 or an 8. And this digit will have to be repeated either there or there. Let's do some more Sudoku. This row still needs 1, 2, and 8. But actually this 2 here by Sudoku goes there. So this is from 1 and 8. 8, 6, there must be a 2 here, it's there. 1, 6, 8. So we're left with repeating this digit, and this digit, I think. Oh, it could be here. Let's focus on easy digits. This row needs a 7, it will be here, and this is from 1, 6, and 8. And this is also from 1, 6, and 8, and it places a 4 there. This 5 here goes there, and it goes there. This column still needs a 3 and an 8, so this is 8 and this is 3. And this 8 goes there, and that's 8. And this is a 1, 6 pair. Now there is an 8 in here, so that's not 8. And let's recall that this digit is repeated here, so those are not 8 either. So now there's an 8 somewhere here, so that's not 8. And I still don't know on which side the repetition goes. This is not a 3 because of this 3, so 3 is here. I need a 4 on this row. I need a 4 on this row, it has to be here, so... Oh, sorry, I need a 2 on this row, and 2 is here. No, sorry, what am I doing? 2 is already here. I need 1, 6, 8, and 7. Oh, but actually by Sudoku, that's an 8. So this is 6, this is 1, this is 6, so the 6 is repeated, the 1 here is repeated, and this is 8, and it can only be repeated in this direction. And I think the rest should be plain Sudoku. Yes, I don't think those last digits need any explanation. This is an 8, this is a 1, and this is a 6. And that's it. Oh, it was quite the ride, but I think I've understood quite a number of important stuff with solving this puzzle by Sylvain. Namely, well, what could I solve? This digit has to be repeated on some green line. That's something interesting. And there are interactions. When some of the green line here has repeating digit, we know that the 6 is not in here. And if this digit here is not is repeated, then it can't appear in any of those cells. So it will have to be either the central cell or the non-repeated cell on some blue or gray diagonal. That is something interesting. A very interesting practice puzzle, as usual by Sylvain. Thanks for watching this video and see you very soon on SudoKanard.